And we're back to the last section of 5.4C. We're going to look at now how to take the integrals of exponential functions and just a bunch of examples of those. All right, so if you remember, when we were taking derivatives of exponential functions like e to the x, derivative of e to the x is just e to the x. Real simple, right? So that means the integral of e to the x is just e to the x plus c. Hey, couldn't get any easier, right? The derivative of e to the u is e to the u, and then remember it's a chain rule, so times the derivative of the exponent. All right, so that means the integral of e to the u du is just e to the u plus c. All right, so we will have to do a lot of substitution here, but hopefully it'll work out really easy. It's almost always the exponent that is equal to u. All right, otherwise we wouldn't have e to the u anymore. So for instance, here's the first one, e to the 3x plus 1. We could say u equals 3x plus 1, and then du equals 3 dx. So this needs a 3. We cancel it out with a 1/3. So this gives us 1/3, the integral of e to the u du. Right? All this was du. All this right here is u, so e to the u du. So we get 1/3 e to the u plus c. Right? The integral of e to the u is just e to the u. And then we plug back in our x's. So 1/3 e to the 3x plus 1 plus c. And there we go. All done. All right, how about the next one? Again, we'll start off with the exponent as our u and see what happens. U equals negative x squared. Du equals negative 2x dx. We've got an x. We've got a dx. We need a negative 2. We'll put a negative 1/2 out front. And this 5 can just move out front too. So we'll have negative 5/2, the integral of e to the u du. All right, so we get negative 5/2 e to the u plus c, which is negative 5/2 e to the negative x squared plus c. Just plugging back in for u, and there we go. Yeah, the trick is that this 5 here, we just kind of move him out front and just kind of ignore him after that. He just stays out there. All right, we'll try and get tougher again. Always try the exponent here. So we'll try the exponent on this guy. We'll say u equals 1 over x. All right, well, if I want to take the derivative of that, I'm going to write that as x to the negative 1. So then du equals negative x to the negative 2 dx, which would be negative 1 over x squared dx. So we have an x squared on the bottom. That works. We've got a dx. We need a negative 1 in here somewhere, so negative inside, negative outside. They cancel each other out. So we get negative, the integral. All this here was just my u, so we get e to the u du. Remember, this negative sign is going down there with my du as the negative 1 on top right there. So if we integrate that, we get negative e to the u plus c. And if we plug back in, we get negative e to the 1 over x plus c. All right, continuing on my rainbow color trend here. Again, we set our exponent, cosine of x equal to u. So then our du is derivative of cosine is negative sine dx. So we need a negative here. We'll put a negative out there to cancel it out. So now all this is my du, and this right here is my u. We've still got the negative outside, and we're left with that. So it's just negative e to the u plus c, or negative e to the cosine of x plus c. Voila, done. All right, we'll try some more now, definite integrals. So same story here. U is negative x. Oops. We'll just go ahead and erase that and start over. Negative x. Du is negative 1 dx. So we just put a negative 1 in here and a negative out there. So we get negative the integral of e to the u du. Notice I leave off the bounds. So we get negative e to the u plus c, or negative e to the negative x plus c. And now I'll go back to the bounds. So we get negative e to the negative x from 0 to 1. So if we plug in 1, we've got negative e to the negative 1 minus negative e to the 0. So that's going to change to plus. E to the 0 is 1. This is minus 1 over e. So we're basically getting that this integral equals 1 minus 1 over e. And we could leave it like that, or we can get a common denominator and it'd be like e minus 1 over e like that. Either one of these is fine. Either one of these is an acceptable answer. You're just matching an answer on the multiple choice at this point, basically. All right, let's see. I guess we'll go back to red. Let's, eeny, meeny, miny, let's do this one down here. All right, so now both of them just have x in the exponent. So if I just said u equals x, that doesn't get me anywhere. So I've got a fraction, and before when we had fractions, we tried to let the bottom equal to u. So we'll try that. So du is derivative of 1 is 0, derivative of e to the x is e to the x dx. Hey, we've got that. Here's an e to the x, there's a dx. So there's our du. And this is u down here. So we're getting the integral of du over u. Well, we just went over that. That's the natural log of the absolute value of u plus e. All right, so we'll go back to e's. So this is the natural log of the absolute value of 1 plus e to the x. And we don't need the plus c anymore because we're going from 0 to 1. So from 0 to 1. All right, we technically don't need the absolute value bars in here because this is always going to be positive, but it doesn't really matter if we keep them. So we get the natural log of 1 plus e to the first, or just 1 plus e, minus the natural log of 1 plus e to the 0, which is 1. So we get the natural log of 1 plus e minus the natural log of 2. All right, we can leave it like that, or if we're subtracting natural logs, we can rewrite that as dividing the inside. So we can write this as 1 log 1 plus e over 2, like that. And there we go. And I guess we'll go back to blue here. Last one here. So we have cosine of e to the x times an e to the x dx. All right, so if we said u is x, that gets us nowhere. If we say u is cosine of x, we're going to need like a sine of x somewhere. We don't have that. Maybe we can just set u equal to what's inside the cosine. So we'll set u equal to the angle there, e to the x. So then du, derivative of e to the x, is e to the x dx. Hey, we've got an e to the x. We've got a dx. So those two together make our du. We don't even have to add anything in. Perfect. And this is our u. So we get the integral of cosine of u du. All right, the integral of cosine is sine of u, technically, plus c. And let's see, we can plug back in our u was e to the x. So we're getting sine of e to the x. Now we're back to x's. So now we remember our bounds are going from -1 to 0. So if we plug in 0, we get sine of e to the 0. Minus plugging in 1, we've got sine of e to the -1. E to the 0 is just 1. So we get sine of 1 minus sine of 1 over e. There's not really any way to simplify that I know of. I don't know what sine of 1 is off the top of my head, or sine of 1 over e. So this is just going to be our answer right there. All right, and that is it for integration with exponential functions. And that's it for 5.4. So check out the homework online.